Hey, 30-2s. Here is your first lesson in a new unit called exponential functions. Okay, first off, what is an exponential function? Well, an exponential function is going to model all sorts of stuff for us in nature. So it's going to model population growth. It's going to model us investing money, either increasing or decreasing. It's going to be the value of my car. It models all sorts of things in nature. But before we talk about those things, what we want to know always is what do these things look like graphically? Okay, grab your graphing calculator. So, an exponential function is simply when we have a variable in the exponent. And how we're going to write these things is in this form. Y is equal to a times a base of b to the exponent of x. Okay, they're going to look very different than the graphs of polynomials, but they're actually nice and easy compared to the graphs of polynomials. So what I would like you to do right now is I would like you to graph each of these two functions in your calculator, hit pause, and try to fill out the chart. Okay, I'll see you in just a moment when you've tried that. Okay, so you went and graphed these things, and here's what you would get. It's going to look something like this. Okay, roughly, it's going to look something like this. Now, in fact, I'm going to show you my calculator, and I'm going to show you that your calculator does a very poor job of graphing these things. So if I go to graph 2 to the exponent x, and I hit enter and graph, it certainly looks like my graph is hitting the x-axis, isn't it? But what I need you to know here in my graph is that it's really not, that it's getting incredibly close to that x-axis, but it's actually not touching it. Okay, there's an imaginary line here called a horizontal asymptote that we will never cross in 30-2. Okay, so let's answer some questions. X-intercept, well, now there are none. Okay, I need you to know that, never in 30-2. Okay, the a value would be the coefficient that's out front, that's 1. The y-intercept, let's always write it as a coordinate pair. It says the b value, which of these two is it? Well, the b value in this case is 2, so I'm going to say the base is greater than 1. The end behavior, we're going to say it ends going up. We could call it increasing. We could call it a growth. We could say it's going from quadrant 2 to quadrant 1. Any of those things are fine. Okay, and the domain and the range? Well, your domain is x is an element of the reals, and since we never hit the x-axis, it's y is greater than 0. Okay, there's the first graph. That's your most basic exponential. And I kind of want you to have that one memorized. If we look at the next graph, what we're going to see again is this time we're going to have a y-intercept at 3, and the graph again, roughly, is going to look like that. Okay, almost looks like the curve of a hockey stick. There are no x-intercepts. The a value is 3, and my y-intercept is 3. Okay, I'm hoping right here that you can make me a link between the a value and the intercepts. Do you start to notice that something's going on there between those two things? Okay. Base, well, the base is 2, so I want to say that the base is greater than 1. And I'm going to say the exact same thing as above for the end behavior and the domain and the range. Okay, so definitely something happening with the a value. Perfect. Now what we're going to explore is you're going to graph these things again, but now you can notice both of these have a base that is between 0 and 1. So I want you to hit pause and go and graph those and see if you can answer some questions. Okay, if you paused it and graphed, what you should see now, what's different about this one, is that it's going like that. And this next one, the y-intercept is going to be right there, sorry, and it's going to do something like that. Okay, so the x-intercepts, well, we still don't have any because I told you we won't have any in 30-2. Okay, the a value, 3 and 2. I'm hoping you can already see the link that that a value is the y-intercept. We'll talk about why that is in a minute. Okay, and behavior, well, instead of calling this thing an increase, I could say it's going down, but a better term for that is it's decreasing. It's still going from quadrant 2 to quadrant 1. Another good term for this would be a decay. Okay, this graph, the same, ditto, ditto. And domain and range are going to be the same as if we were increasing. X is an element of the reals, y is greater than 0. Okay, so you can see these are really, really basic graphs. And again, I just want to point out, it looks like your calculator is hitting the x-axis, but it never is. Okay, it never will in 30-2. So here's the real important parts from today. What characteristic of the graphs is associated with the a value? The a value is the y-intercept, or when we get to an application, we're going to call it the initial amount. Okay, will this always be true? Yes, in 30-2, not if you take 30-1. How does the b value affect the shape of the graph? Well, the b value tells me if b is bigger than 1, then we're increasing. If b is between 0 and 1, then we're decreasing. We're an increase or a decrease, a growth or a decay. It also tells me the bigger the b value or the smaller the b value, how quickly the graph increases or decreases. Okay, do the graphs ever cross the x-axis? Nope, not in 30-2. Okay, the reason is, friends, if we look at something like 2 to the exponent x, any value you sub in for x will never make y equal to 0, or even any number smaller than 0. So that's why that's always true. Okay, again, only in 30-2. And what would happen if b was 1? You notice we skipped that. It says b is bigger than 1, b is smaller than 1 but bigger than 0. Well, if b was 1, friends, what would happen is you would have 1 to the exponent x, and anything 1 to the exponent anything is just 1. What you end up with is a straight line and not an exponential. So we'll never deal with that. Okay, there it is. There are the characteristics of exponential graphs.